Hi, everybody. I've had a couple of people ask me about this exercise sheet, number 8. And so I thought maybe I'd take the time to make a video to do a couple of the questions with you, go through the process, do the math as an example. Some of you have already handed in the labs, so that's great. I'm going to assume that that means that you're comfortable with this information. I haven't looked at them yet or marked them. So if you watch this and discover that you weren't doing it right, then feel free to do it again and resubmit it. If you're comfortable with the material, you probably don't even need to watch this video. This is for the benefit of those who need a little bit of a walkthrough. So let's do that. We'll do question 1, question 4, and question 5 here on the exercise sheet 100-8. Okay, so question 1. So all of these are about about the resistance of a conductor. Okay, so for all of these, the equation is going to be R equals KL over CM. Okay, so ultimately we have to plunk the right numbers into those variables. Okay, so K is the specific resistance of the material that is the conductor. Length is the length of the conductor. Remember, in feet. Okay, this is all imperial stuff, not metric. And divided by the circular mill area of the conductor. Okay, so that's our equation. Let's figure this out. So the first one, I just thought I'd do this because it's a nice introduction. Let's figure this out. So with this equation, calculating for the resistance, what is K? Question 1 says a copper conductor has a circular area of 250 circular mills and a length of 825 feet. Find its resistance. Okay, so it's a copper conductor. So K is going to be 10.4 ohms multiplied by the length of the conductor in feet. We're told it's 825 feet. Divided by the circular mill area. And we're told it's 250 circular mill. So when we calculate that all out, the 10.4 ohms times 825 divided by 250, and the order of operation here doesn't matter, multiplication and division, whether you multiply these and then divide it, or whether you just plunk it all into your quick calculator and let it figure it out, it doesn't matter. You will end up with 34.32. 34.32 watt. Okay, we could actually get in here and we could figure out how all the units cancel out and so on and so forth. But at the end of the day, what we're calculating is resistance, which means the number that we come to is a value in ohms. Okay, so that's question 1. Fairly straightforward, just a good place to start. Let's move on. Because question 4 and 5, they introduce some other components. So it's a nice opportunity to talk about some other things as we go along as well. So question 4, it's a tungsten filament. Okay, so that's the first piece of information. All that means, the only thing that changes is our value for K. We're going to have to know what that is. Okay, it's 10.4 for copper. It's 17 for aluminum. I do expect you guys to remember those numbers. Anything else, you'll be given that information. Okay, so the question actually tells us that a tungsten filament has a specific resistance of 33 ohms per mil foot. So there's the number that we're going to use. So if R is equal to KL over CM, then K is going to be 33. 33 ohms multiplied by, now what is the length of this tungsten filament? Well, it's 6 inches. So can I just put a 6 there? No, because that's 6 inches. Remember, L is in feet. So 6 inches is how much of a foot? It's half a foot, right? So it's 0.6. Sorry, it's 0.5. It's 1/2 of a foot. So 0.5 feet is the length of this conductor. Okay, divided by the circular mill. So what is the circular mill? Well, we have to do a little bit of work here because we are told that this tungsten filament has a diameter of 128ths of an inch. So 3 over 128 equals, if we do that math, 3 divided by, where is that, is 0.0234 inches. Okay, now what's the first thing we want to do is we want to translate inches to circular mil. So that means we're going to move the decimal place 3 times to the right. So 1, 2, 3 means this is equal to 23.4 mils. Okay? Can we use that number down here? No, we're not there yet, because circular mil is the value that we need here in the denominator. That's the circular mil area. This is still just the diameter. Okay? So area circular equals d squared, which equals 23.4 mils squared, which equals, I have that number right here, 549.3, I almost wrote square mils, that is circular mils. And that finally is the number that we're looking for to put into our equation. So 549.3 circular mils. And now we can calculate that out, and we get an answer of 0.03 ohms. Okay, is the resistance of this tungsten filament. Okay, so that's how we do question 4. Question 5, there's a little bit more work involved yet, which is why I really like this next one, because it gives us a chance to talk about the work that you would have done back on exercise sheet 7 as well. We're going to have to really back up. So for starters, remember that R equals KL over CM ultimately is what we're trying to accomplish. And what are we told? This time it's a rectangular carbon brush, and we're told the dimensions of the rectangle. Has a length of 1 inch. Find its resistance, and we're told that for carbon, the specific resistance, this is a huge number. So we know K. K is, what is this? It's 21,052. Okay, next is L. What is L? Well, it's 1 inch. Okay, so we can't put a 1 in here. Okay, 1 inch is 1/12 of a foot. So what is 1/12 of a foot? It is, it's a really nasty number actually. It's kind of 0.083. If you do 1 divided by 12, that's the number that you get. So another good reason to not really like the imperial system. The metric system actually turns out to be nice and friendly. We never end up with strange numbers like that. But nevertheless, that is the decimal value of 1 inch expressed in feet. Divided by circular mil. So here's where we've got some work to do, because what is this? This is a rectangular conductor. So first thing we're going to calculate is the square area. And square area equals length times width. Well, what are these numbers? Well, we've got some more work to do yet, because the one side measures 1/4 of an inch. 1/4 of an inch equals 0.25 inches, which 1, 2, 3, once we move the decimal place 3 places to the right, we end up with 250 mils. So that's the first side. The other side is 3/8. So 3/8, 3 divided by 8 equals 0.375 inches, which is equal to 375 mils. Okay, so we can take that back over here. The square area is 250 times 375 is equal to 93,000 750 mils squared, or square mils. Okay, 93,750 square mils is the square area. Still can't use that here in our equation because this is circular mil. So how do we translate from square area to circular area? So area circular is equal to area squared. And now we have to decide, the conversion number is 0.7854. We have to decide whether we're going to multiply it by or divide it by. So remember, if we have one circular area, that's a smaller cross-sectional area than one square area. Okay, this is a smaller unit of measurement. All right, this is 1 centimeter compared to 1 inch. Okay, smaller unit of measurement means to measure the same thing, it's going to have to be a bigger number. All right, so in order to take this number, which is our square area, and turn it into a bigger number, okay, and our conversion number is less than 1, if we divide by a number that's less than 1, we end up with a bigger number. And so that's what we're going to have to do here. It's going to have to be divide by, and our conversion factor is 0.7854. So we take our square area, 93,750, divide it by our conversion factor. A number less than 1 will result in a bigger number, and we get 119,365.9 circular mils. Okay, and so finally we have the number, the circular mils, the circular area, which is what we need in our equation to calculate our resistance. So it's divided by 119,365.9 circular mils, which gives us 0.0146 ohms as the resistance of this carbon brush. So the resistance, the specific resistance of carbon is extremely high. But the reason the resistance ends up being very small is because it's so short and fairly big. Okay, so we end up with a small number for resistance. But that's the process. All right, so there's a number of steps involved in getting from the beginning to the end. Okay, but if you focus on your goal and just figure out how to find each one of these variables, okay, and so this is the important one, the circular mils. We had to do some work to get there, okay, but that's the step-by-step process to work through that question. Okay, next I'll have a much shorter video which will just be about the temperature coefficient. We'll go through the process there, and then we'll be ready to move on.